All right, here we go. Shout out to Maddie Lindley, star quality of toughness. She's going to surgery. Who has some words for Maddie?
You're awesome.
Bree doesn't know how to talk.
Oh, hi, Maddie.
That's Maddie. Happy birthday, Maddie.
Hi, Maddie. I hope your bunion surgery went well. Barry will be deeply missed.
That was Catherine. Here's D. Weiland.
Keep the scooter for as long as you can.
Whoa. Do it, sir.
We hope you feel better tomorrow.
Do it. Will you have Leanne make some Scotch rhubars for her?
I can ask.
He can ask. Okay, all right. I'm sorry. Here's Kelsey.
Hi, Maddie. Send me pictures.
Sean?
Hola.
Wow, Spanish.
Hi, Maddie.
That was Darren. He always has a lot to say.
Hi, Maddie. Just remember, you can always ask me if you need something.
Isn't that nice? Oh. And here's Dumb and Dumber.
Do math.
That's from Caleb. Do your math.
Hi, YouTube.
Wow.
Hope you feel better.
There's Caleb. Look at Wally.
I want to ride on the scooter.
Wally wants to ride on your scooter.
I'm sure you'll make it through just fine.
Sarah says she's sure you'll make it through just fine. My message to you, Maddie, is suck it up and just push through. Okay? I'm sure you'll do great. We think you're awesome. We miss you. Class is so boring without you. All right. Okay, here we go. Let's get to it. We got some notes. Find the area bounded by x to the fourth and 2x squared minus 1. This is going to be a helpful problem, help you save some time. What does x to the fourth look like? Yeah, if it had other terms to it, look like that, but just x to the fourth, it actually looks very similar to just a parabola, yeah. It's just maybe a little bit steeper, okay? And then y equals 2x squared minus 1. That's a parabola that shifted down 1 unit. And, kind of raises a question here. And the question is, well, do these intersect? Does it go on the outside? Does it intersect twice? And we don't really know that until we set them equal to each other and we solve for that intersection. Because it says find the area bounded between the two. So we got to look at kind of what that area looks like. Well, if we set x to the fourth equal to 2x squared minus 1, and I add it over, I get x to the fourth minus 2x squared plus 1 is equal to 0. What do you think of that? Does that factor? X squared minus 1 and x squared minus 1. Yeah, 1 and negative 1, and then 1 and negative 1. Right? So you see that that 1 and negative 1 both happen twice. That literally means that they're double roots. It means that they literally touch tangent. Okay? They just touch once and head on off. So we're looking for this area right here. And as I draw a rectangle, I'll draw it in green. Okay? I can see my top and I can see my bottom. Okay? That rectangle, does it have horizontal width or vertical width? Horizontal width. The width is dx. And what that tells us is that our integral is going to have dx, so our boundaries have to have x as boundaries, and our function for our integral has to be in terms of x. So what are the x values for our boundaries then as we integrate, as we move the rectangles from left to right? -1 to +1. So what sits on the top? X to the fourth. What sits on the bottom? So as we subtract them, we have x to the fourth minus 2x squared minus 1. Now, before we move any further, I'm not really looking forward to plugging in that -1. And so I'm going to find a way around it. And some students kind of get lost during this time, but some of you will find that this makes things a lot easier. Do you recognize that this shape is symmetrical about the y-axis? Yeah, the area is the same on the right side as it is on the left side. That's because these two functions are both even functions. If you notice, we have x to the fourth, we have x squared, and then this is an x to the 0. All of the numbers are even. And if they're even, it means that they're reflected about the y-axis. So I can make this problem a lot simpler. What I can do is, instead of going from -1 to 1, I could go from 0 to 1, and then what would I do with the area? I would double it. So what I'm going to do is I'm going to find this black shaded region right here, which is going to be the same on the left side, and so I'll just double it. And that way I get to plug in 0. And plugging in 0 is always a good thing. So, yep, it's wonderful. And I think the world existed for many years without the number 0. So, x to the fourth minus 2x squared plus 1 dx. It came from this change of bounds, so that's technically how we see that. So the antiderivative x to the fourth is x to the fifth over 5 minus 2x cubed over 3 plus x. We're going to integrate from 0 to 1. We're going to multiply the whole thing by 2. So I plug in 1, I get 2 times the quantity 1/5 minus 2/3 plus 1. When we plug in 0, we get 0. What would be the common denominator here? So 3/15 minus 10/15 plus 15/15. And 3 minus 10 is -7 plus 15 is 8 times 2 is 16/15. That is the exact area bounded between those two curves. Pretty cool. Monday and Tuesday, we will be doing AP review focused during the day. You have no assignments in the that you'll take home those days. On Wednesday, you have all day to ask questions on your study guide, but you shouldn't come with none of your study guide completed on Wednesday. The idea is that you have this weekend and Monday and Tuesday to be preparing with your study guide and then ask questions on that Wednesday. And if you guys want me to, I'll take a couple questions on the study guide on Monday and Tuesday if you want, right at the beginning of class. But don't save everything for Wednesday. Yep. That's correct. None of this content's on the final exam. Okay. So, all right. We'll move along. Next problem. The key is to always make sure you have a good understanding of what your area looks like. And we're actually going to use our calculator for this one, okay? So let's just admit right now that we can use our calculator for the entire piece, okay? Yeah. All right, so what I'm going to do is, just because I have a general idea already of what this looks like, I'm going to factor out an x, and I get x squared minus a 3x plus 2. And then that factors to x minus 2 and x minus 1. Everybody see that? So this graph, and we'll confirm it on our calculator in a second, passes through these 3 points on the x-axis. Passes through 0, 1, and 2. Now the next graph is y equals 2x minus 2. What does that look like? Very good, it's a line. And it's going to go up to and over 1, so the line looks something like this. So can you see this, the shaded region? Now, a lot of people in this situation, they say to themselves, well, big deal if we have to use our calculator. That would be just really easy to find the area. Well, I don't think so. I mean, let's look at our calculator. We turn it on. We type in the functions. I have x to the third minus 3x squared plus 2x. And then I have 2x plus 2. 2x minus 2. And as you zoom standard, and you look at these graphs, so what are you going to do? You're going to second calculate 7, and you're going to go from, I don't know, -2 to 3? Is that, I mean, is that honestly, does that look like the shaded region that we want? It doesn't work like that, folks. We have to think more critically about what's happening. So we'll still use our calculator, but I want to find some intersection points, don't I? Okay. So I can calculate. Intersect number 5. So first curve, second curve, great. So it looks like this intersection point right there happens at x equals 2.73. And in honor of the AP exam, we'll go to the nearest thousandth. Anybody want to guess where this intersection point is? It is 1. If we did intersection again, number 5, you just have to move closer to that spot. So your calculator is doing a type of Newton's method as it solves for this, and it wants you to give good guesses along the way. And so we get 1. I know you guys remember Newton's method, so don't forget anything in math. And for the last one, second calculate intersection number 5, and we'll have to go over here. Kind of ruined my drawing by having all that area sitting there. But it looks like this happens at x equals -0.73. Oh yeah, what is it? 2? Dos. All right. So let's write an integral now. What would the first integral be? The 1 of x cubed plus 2x, good. And then minus 2x minus 2 dx. We're going to have horizontal width as we look at these rectangles, as we draw them. Okay. Good. Plus another integral. Where would the second integral start? 1. And then they would just switch, right? I'd have 2x minus 2 minus x cubed minus 3x squared plus 2x dx. So, you know, the AP exam, they would give you this type of problem. You would then, you know, you use your intersection, great. But, you know, you actually have to plug this in. So notice that my calculator isn't able to say, well, I'm going to find the area between the two functions. It wants you to actually write the integral itself. So let's just do the first one. We've got parentheses x third minus 3x squared plus 2x and then minus 2x minus 2. I'm going to calculate number 7. Notice it just gives me one function. And I go from -0.732 and I go all the way to 1. And notice it finds that nice little section, that positive area. I get 2.25. Now, these just switch values from positive to negative, right? So if we use our calculator, we don't actually take the antiderivative. So now I go I go back into y equals. I'm going to insert a negative sign here, and I'll make this positive, and that's going to switch my graph now. So now if I second calculate number 7, you can see that before that was below, wasn't it? And that was above. So now it's going to find this little area right there. If you're finding area between two curves, it will always be positive. It will never be negative. Never. And so we go from, what, 1 to 2.732. What did I do? Okay, and we get 2.25, which is 4.5 when we're all said and done. Look at what we've done. Right? Because when we actually write the top minus the bottom, this is a function on its own, right? Yeah. Yo. You're asking a really good question. I try to answer it. One shot for you guys. If I can, I'll show you. If you guys just, and this will take us right to the belt. The next problem takes a while, so this is a good spot for us to kind of talk a little bit. So the question at hand is about just looking at the area and different situations like that. If I have something like this, watch this, okay? This should click. Y equals, I'm going to go 2 minus x, and then y equals 1. You okay with that? Now I'm going to find the area, and I'm going to refer to this area right here. Y equals 1 is a horizontal line, and 2 minus x looks like this, right? So I'm really finding just this area, right? What's the top function? 2 minus x minus the bottom function. What does that become? 1 minus x, right? So if we then graph that, here's what the graph looks like. The graph looks like shifted up 1, slope of 1. That's what we're finding the area, right? See? It's just simply, when you subtract the two functions, it just expresses the area in a different way. It's the same area. I know that this area that you guys just looked at right there, I know that that piece doesn't look identical to what we drew here, but it's the exact same area. It's just represented in a little bit different way. Just like when I did this part right here, just like when I drew this graph is shifted up 1 unit from this, right? Still the same area, right? I mean, you could stretch it by a factor of 2 and then by 1/2 on that side, still say, well, we just changed it. We just made it look different. Still same area. So that's what the problem does. Anyway. Can you ask that question one more time? Here, they did not give us any points. So we were strictly going for the intersection points. If we wanted to bound by the x-axis, it would need to say that. Okay, let's at least start setting this up so we can wrap our brains around a little bit. What's different about our last problem? Yeah, we got this x equals thing here, okay? Now, this will throw some of you guys for a loop, and this is a common problem people don't get right on the test. So, you really want to think this through a little bit. But if it was y equals x squared minus x, what would it look like? A parabola that went up, right? So this is a parabola that goes to the right. This is x equals y times y minus 1. So it's a horizontal parabola that passes through y values of 0 and 1, which is totally cool, right? And there's my graph. How about 2x minus 2? Yeah, we just drew that one, didn't we? So these are my two functions. can you see the area between the two curves? Watch what happens if I try to draw a rectangle. What's on the top, the parabola or the line? Parabola. What's on top, the parabola or the line? And the bottom is the line, right? What about when I do it here? Parabola's on top and bottom. And if I subtract them, what happens? They just go away. So we can't draw rectangles like that. We have to draw rectangles like that. And that looks like a good place to go get some brain food. Get out of here. Perfect timing. Maddie, we hope you're doing well. Here we go. So we are at this problem. You see that we cannot draw vertical rectangles. If we drew vertical rectangles, why would it not work? Yeah, there's a portion where the top is the bottom, right? And that's problematic. You can't have the top be the bottom. When you subtract, you get 0. So what I do instead of top minus bottom is I do right minus left. Right minus left. Okay? So the thickness of the rectangle, does that have a thickness of dx or dy? That has a thickness of dy. So my integral will have a dy in it, which means that I need a y equals value up here and a y equals value down there. And everything has to be in terms of y. Now, if I do right minus left, what's on the left-hand side? The parabola. So I have y squared minus y is on the left-hand side. So I'll be subtracting that. The line is on the right-hand side, but it has to be in terms of y. So right now it's expressed in terms of x. You have y equals 2x minus 2. Yeah, so I have, y plus 2 equals 2x. dy one says divide by 2. So 1/2 y plus 1 is equal to x. So we'll go 1/2 y plus 1. Now I've got everything in terms of y, but I need my boundaries. I need to know what this y value is right there, and I need to know what this y value is right there. Find the intersection. In order to find the intersection, this is what x is equal to. I'll use substitution and plug it in for x there. See that? Y equals 2 times y squared minus y. And I have a minus 2 on the end. Distribute my 2. Y equals 2y squared minus 2y minus 2. Subtract the y over. 0 equals 2y squared minus 3y minus 2. Factor 2y and y. What? I'll have a plus 1 and a minus 2. So solutions are so we got the algebra, right? Big deal. We did that back in 9th grade. But what do they mean in context of the problem? Yeah, this y value right here is negative 1/2. Does that look like it could be negative 1/2? Does this look like it could be 2? That actually looks like that's a pretty good representation. It's like my smartboard got dumb right now. Come on. There it goes red. Sorry, Maddie. We're waiting. Okay, there we go. We got y is equal to 2 here. So now I've got my boundaries. I go from negative 1/2 to positive 2. So what you're literally doing, you guys, is you're stacking these rectangles. And you're starting to stack them at this negative 1/2 spot. You're just continuing to stack more and more and more and more. And each one has a thickness that's infinitely small. It's dy. That's what we're doing. We're just layering them from the bottom all the way to the top. That's what this is accomplishing. So I'm going to get rid of this. I'm going to evaluate. I'm not going to use my calculator because we're going to show the star quality of number sense. Make it up as we go. Self-confidence, whatever. So we got the integral from -1/2 to 2, and I'm going to combine some like terms here. So I'm going to have a negative y squared, 1/2 y minus negative y, positive 3/2 y, and I'll have a positive 1 dy. dy ln. So what is it that we do now? Calc. Antiderivative. So we get negative y cubed over 3. Yep. Plus 3y squared over 4. Plus y. Well, aren't we all just in the mood of complimenting each other today? Killing it. Okay. Wasn't going for death, but so now we plug in 2, and I get negative 8/3 plus 3 plus 2 minus, what's negative 1/2 cubed? Negative 1/8, and then multiply by the negative, I get a positive 1/8 divided by 3, 1/24. Good. Negative 1/2 squared. 1/4 times 3 is 3/4. Divided by 4 is 3/16. And minus a half. What's going to be my common denominator? It will be 48. So I need to multiply by 16. 8 times 16 is 128. 3 plus 2 is 5. And 5 times, oh, we said 48. 48, sorry. And 5 times 48 is 240. Minus denominator 48. Everybody can do this one. 2 over 48. Minus 9 over 48 plus, yep, distributing my subtraction sign. Okay, so we know our final answer is going to be over 48. Negative 128 and positive 240. 112. What? Minus 2. 110 minus 9. 101 plus 24. 125 over 48. And that is simplified. Sorry, Maddie. We're listening. Maddie is going off right now about Logan and who? Chase and Zoe and Zoe 101 and wow. Yep. I don't know the show, but sounds like there's a lot of passion involved. There you go. That was from Thursday. That's for Friday. True or false? You will receive a homework assignment on Monday. True or false? You will receive 0 homework assignments on Monday, Tuesday, Wednesday, and Thursday of next week. True. You will get an assignment that will review area. So we're going to review area. We're going to do calculator stuff and stuff by hand next Monday or next Friday, right before we go on spring break. And then when you get back, we'll start doing volume. So you can start a new assignment. I don't care, or add it on. It's up to you. But these are your 2 assignments so far. Please don't put this off, folks. Again, these are the notes that you get to use for the test. This is not a super high scoring test. I expect you to bounce back from the previous test. I do. It is open homework. It is open note. It is open book. It is not open phone. It's not open me. It's not open partner. Yes. So 3 and 4 are now today. Because now the 3 and 4 are integrating with respect to y. So it'll be a dy. Maddie, we miss you.